Hello, I'm Kim Chan-soo, the presenter of this term project. This is my second term project video. I will start now. At last, my project target was 3D printer. 3D printer is one of the well-commercialized equipment. There are various systems interacting together, so I thought the 3D printer is suitable in this term project, and I want to express the system. So, I expressed this block diagram, LS first PPT, and it looks like this. In this block diagram, this is the sensor, this is a heat, and this is a motor part. To express it in the BG program, in its elements, but there's no elements in the heat and the motors. So I have to add it, and I have to delete the sensor because in BG program there's no elements for a sensor. So the result looks like this. I added R and I in the motor because the motor has inertia and resistance. I I guess that the motor's power came from this SE. So other power source is deleted. And in heat, all electric is changed to the heat, so I expressed as just R. So in BG program, I draw it like this. As seen in the bond graph, there's no any derivative causality, so causality was clear. After the causality scan, I exported the metric file for this, and I used the Mathematica to get the state equation for this bond graph. And the result is seen like this. Here's just one input as a bond graph, and there's 4 steps for each motors. And the parameter is gyrator, inertia, and resistance. The matrix under one is very important because this is the constant for the state equations. The state equation looks like this. So we know by the Mathematica, we know the x1. And in CD, I use the matrix for the part that I want to know. So with these state equations, I want to get the system flow simulations by the MATLAB. So any constants, I set the constants as 1, and I put the result to AB from the Mathematica. The motor has the four motors has same each other, so I just check the one motor, the extruder one, because others same. And this is the result. It is very smoothly up to 1, and I changes the R value to see other result. And so instead of 1, I input the 0.1, and the result is like this. And I I give the 10 to R, and the result was this. So I can know that if the R increases, the time for the stability has decreases. This is up to my bond graph simulations, and thank you for watching.